Hello everyone, this is G42 and today we are going to present the part 2 of our project. Today I am Vallabhi Upadhyay, roll number B21026 and I am going to present the introduction of our project. So let's get started. The title of our project is DDoS attack detection. DDoS or distributed denial of service is an attack or one of the most dangerous attacks in the field of network security. So let's first discuss what is DDoS attack and how does it work. It is a malicious attempt to disrupt the normal traffic of a targeted server or a network by overwhelming the target with a flood of internet traffic. It is carried out with a network of IoTs or internet connected machines. DDoS or distributed denial of service is a subcategory of a more general denial of service or DOS attack. In a DOS attack, the attacker uses a single internet connection to barrage a target with fake requests or to try and exploit a cybersecurity vulnerability. DDoS is a larger scale. It utilizes thousands, even millions of connected devices to fulfill its goal. The sheer volume of the device used makes a DDoS much harder to fight. Um, the networks that carries out the attack are computers or other devices which are hampered by malwares that allows the attacker to control them as per his wish. Such hampered devices are called bots or zombies. A group of bot is called botnet. So when the victim is targeted by each botnet send requests to target IPs causing overwhelming of network. Now, how do we identify these DDoS attacks? So first, we identify those users who share single behavioral profiles such as device type, geolocation, or web browser versions. We can also identify unexplained search in requests to a single page or endpoint. We can identify old traffic patterns such as spikes at the odd hours of the day and so on, like spikes in every 10 minutes. There are other signs of DDoS also that can depend on the type of the attack. So we can identify them using these types also.
Hello everyone, my name is Deepika and my roll number is B21288. Here I am explaining about the dataset we have used in the project DDoS. So the dataset we have used here is SDN dataset. This dataset contains 23 attributes, out of which one of the attributes is labels. The value of label attribute are 0 and 1, where 0 corresponds to ban-in request and 1 corresponds to malicious request. The algorithm we have used here to create our model to detect DDoS attacks are random forest, KNN, and logistic regression. And we have compared the accuracies of all of the three models using accuracy score and F1 score. Now in this slide, we have a snippet of the code in which we have imported all the necessary libraries which will be used in creating our model. For the algorithm of KNN, we have imported K-neighbors classifier library from sklearn.neighbors. For algorithm logistic regression, the library logistic regression is imported from module sklearn.nsample. For algorithm random forest library, random forest classifier is imported from sklearn.nsample. Now, for calculating accuracy, we will import accuracy score library and F1 score library from sklearn matrices module. A report of all the accuracies for a model can be obtained by using classification report library from sklearn matrix module. We will also need to split our data into test data and train data as to create a model. So we need to import train test split library from sklearn.model selection. Another library standard scalar forms sklearn.preprocessing is used, which is very important for standardizing our data at the initial step of data processing in order to get a precise model. Now, here we see a pie chart which is denoting the percentage of benign and malicious requests. And as already discussed, the label value corresponding to 0 denotes benign request, while the label value corresponding to 1 denotes malicious request. As we can see in the pie chart, our data contains 60.9 benign data and 39.1% of malicious data. Now, in this slide, we have seen a histogram for the duration of request is plotted, from which we can conclude that there were a lot of requests for a very short period of time. In this, we have also analyzed our data and found that Two of the attributes have some null values in them. This information is very important for the processing set as null values will hidden in our model creation. Thank you.
Hello, my name is Shambhu Vidhar. My roll number is B21022 and I will be taking it up from here. After importing all the libraries and plotting the pie chart, we will calculate the number of missing values in the data using .isNA.sum. We also plot the number of missing values in each attribute using .plot.bar. We have also plotted histogram representing duration of requests using plt.hist. After doing this, we find out the total number of requests and total number of malicious requests from our data set so as to get the general idea of these parameters of DDoS attack. We first find the number of requests from each IP using .src values.counts and then plot it using plt.barh. Using the same function, we also calculate the values of malicious requests from each IP and then plot the graph. We then merge both the graphs using plt.legend. We can infer that 10.0.0.10 IP is sending highest number of malicious requests. Then we perform the same comparison between malicious requests coming from each protocols and plot the graph. We can see that UDP protocol is the protocol which has the highest number of malicious requests. Next, we start data preprocessing and splitting. Coming to why we need data preprocessing. It is essential to preprocess data before its actual use. It refers to the concept of changing the raw data into a clean data set. The dataset is pre-processed in order to check missing values, noisy data, and other inconsistencies before executing it to the algorithm. Next, we start data preprocessing and splitting. Here we use pd.getDummies, which allows us to easily one-hot encode our categorical data. One-hot encoding turns our data into a binary vector representation. This means that for each unique value in a column, a new column is created. The values in these columns are represented as ones and zeros depending on whether the value matches the column header. We also use standard scalar function that removes the mean and scales each feature or variable to unit variance. Finally, we split our data into 70% training and 30% testing data, over which we test and train various machine learning models like KNN, random forest, PCA, etc., and check which model yields maximum accuracy. Thank you.